In this video we are going to explore the standard form for an ellipse equation, but as a general overview, let's remind ourselves that under the heading of conics we have the parabola, we have the circle, we have the ellipse, and we have the hyperbola. These are all examples of conics. And here are some general equations of conics, and the way to tell which conic you have from looking at the general equation, or which conic you may have, is by looking at the squared terms. So in this first term we only have a y squared. Anytime just one of your variables is squared, then you have a parabola. If two of the variables are squared and you are adding, and the coefficients of the squared terms are the same, then you have a circle. If you're adding and you have two squared terms but the coefficients are different, then you have an ellipse. And then when you are subtracting, so that one of the squared terms is negative, and it doesn't matter what the coefficients are, but when one of the squared terms is negative, you have a hyperbola. All right, so we are going to erase these, and we're going to put the standard form of an ellipse equation here, and actually just like for the parabola, there are two forms of this equation. X minus h squared over a squared plus y minus k squared over b squared equals 1 is one form. And in the second form, I'm just going to swap the a and the b. So x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, so the important thing to note in ellipses is that you have these numbers in the denominators that are squared, but they have to be different. If they're the same, you have a circle. So they're different, and the way to tell which one is A and which one is B is that A is always bigger. So it is important to note that A is bigger than B. All right, so that means that this one, the term under the x squared is larger. But in this equation, the term under the y squared is larger. All right, well, when A, the larger number, is under the x squared, then your ellipse is more horizontal. But when the larger term is under the y squared, then your ellipse is more vertical, and we'll see why. Let me give you an example equation, and we'll just use it to explain how these work. So let's suppose that my equation is x minus 3 squared plus y squared, and we'll put 16 under x minus 3 squared, and we'll put 36 under y squared equals 1. Now these do not have to be perfect squares, but I'm going to make our numbers simple to make the explanation a little easier to follow. So in this equation, I have three pieces of information that are going to help me to graph my ellipse and to understand my ellipse. All right, the first thing is that we have an HK just like we did for parabolas and just like we will do for circles, ellipses, and hyperbolas. Now, in the circle, the HK is the center. In the parabola, the HK is the vertex. Circles don't have vertices. Parabolas don't have centers. But ellipses and hyperbolas have both. And so in the ellipse, I have an HK. The HK for the circle, the ellipse, and the hyperbola is always the center. So the center of my circle, or my ellipse, is 3, 0. If I don't have anything sitting here with the y, then the coordinate is 0. So the center is 3, 0. Now A and B are going to help me draw my ellipse, and A is going to help me identify my vertices. So I'm going to define A and B. Well, we can see that the larger number is 36. So that means that A squared is 36, and that means that A is 6. All right, means that B squared is 16, which means that B is 4. I need to know A and I need to know B in order to sketch my ellipse. And so here's what the sketch of this ellipse is going to look like. All right, my center is 3, 0. So 1, 2, 3, and there's my center. Now, an ellipse is going to be longer one way than it is the other. In this case, my largest number is under the y squared, so I have a vertical ellipse. That means that I'm going to go 6 units away from the center on both ends to get my vertices. So I'm going to go 6 units up, All right, so here's one vertex, and then I go 6 units down. And here's the other vertex. These are my vertices of my ellipse. They're my extreme points, okay? Now, I'm going to use B to get my co-vertices. These are the other end points that I use to draw my ellipse. And since B is 4, I'm going to start at the center, and B is under the X, so I'm going to go in an X direction to get my co-vertices. I'm going to go 4 units. So 4 units to the right, 1, 2, 3, 4, and 4 units to the left. Puts those points there, and so now I have my ellipse. I can sketch it. Now it's not going to be very pretty. Ellipses are hard to draw for most of us. We don't really care what it looks like, as long as it's accurate. So from this, we've written the center. Now we can identify what the vertices are. A is the distance from the center to each vertex. That's what A tells you. And so I can identify on my graph that my vertices are at 3, and then 1, 2, 3, 4, 5, 6. So 3, 6, and 3, and then negative 6. 3, and you can write plus or minus 6 if you so choose. All right, these are my vertices. Okay, now there's one more thing that we want to identify on our conics, and true for the ellipse as well. I'm going to put B up here just so we remember what B has to do with my picture. All right, and the last thing that we want to identify are the foci. Now, an ellipse has 2 foci. Remember that a center doesn't have a focus. A circle doesn't have a focus. It has a center. And the parabola has 1 focus. But the ellipse and the hyperbola both have foci. They have 2. And they're always on the major axis, this axis that goes through the center and contains A. This axis is your major axis, and the shorter one is always your minor axis. So the major axis, in this case, is vertical, and the minor axis is horizontal. All right, this says major, but you can't see it. All right, so you have major and minor axis. The longer, you have a major axis and a minor axis. Now, my foci, I use the letter C to get my foci. They're going to be points along here. All right, so let's put foci right here. I need C in order to get these 2 points. Well, what is C? There's an equation that we use to get C. And the equation is C squared equals A squared minus B squared. All right, well, in this ellipse, A squared is 36, and B squared is 16. So C squared equals 20, which means that C is the square root of 20. You can simplify that and say 2 square root of 5. That's C. I'm going to use that to write my focus. Now, the square root of 20 is between the square root of 16 and the square root of 25. So it's between 4 and 5. You know, let's say about 4.6, since I'm just estimating here to put my point. So 4.6 units up, 4.6 units down, and there are my foci. But to write my foci, I start with the center, and in this case, I'm adjusting the y on that point. So the x-coordinate of my center stays the same, but I go up and down by 2 square root of 5. So plus 2 square root of 5 is one y-coordinate, minus 2 square root of 5 is the other y-coordinate. If you want to, you can write the foci all in one, in this case, like this. You can't always do that, but of course we can do that here. So there's my foci right there. These 3 things are the important pieces of information about your ellipse.